The James Webb Space Telescope just spotted something amazing. It looks like light beams zipping out from what could be a city on a planet way out there. This has everyone buzzing about whether there might be alien life after all. The telescope was pointed at Proxima Centauri b, our closest planet neighbor, and saw these weird bright flashes. Could this be a signal from aliens? We'll have to wait and see what happens next. People have always wondered about life beyond Earth, right? Any little hint gets us excited. But when the James Webb Space Telescope showed what looked like actual evidence of life out there, it was a game-changer. While scanning deep space, the telescope found something incredible. On a faraway planet, there were lights that looked like city lights, making us wonder if there's an alien city on that planet. Scientists are super excited about this. It could be the thing they've been waiting for. It suggests maybe there are smart beings somewhere running things in ways we don't even know yet. These city-like lights are super far away, 4 light years. NASA folks are blown away, wondering how long these lights have been out there, just waiting for us to get the tech to see them. David Kipping, an astronomer at Columbia University, says this planet is pretty special. Most rocky planets soak up sunlight and spit out energy as infrared, but not this one. It acts differently because of its cool with its star, Proxima Centauri. The James Webb Space Telescope really came through here. Its ability to see infrared light was key to spotting the weird way Proxima Centauri b acts, which is important for figuring out what's going on with its air. Researchers are going to keep using the telescope to check out the planet's air more closely, hoping to see if it could be a place where life could live. The James Webb Space Telescope is great at picking up infrared, so it can see what's happening on Proxima Centauri b even at night. Other telescopes struggle to see dim light in space, but this one's a pro. That makes it the right tool to see if those city lights are really there on the dark side of the planet. The telescope can spot man-made light in space, but it has to be at a very specific frequency, much smaller than the light from stars. Proxima Centauri b and its star have a close connection, which really shapes the planet. Like other planets, it gets a lot of energy from its star. As it goes around the star, it has day and night. Like Earth, it gets super hot during the day and cooler at night. The temperature on Proxima Centauri b jumps around a lot, mostly because of what it's made of. If it has air, the temperature change between day and night would be wild hot on one side, freezing on the other. Astronomers are really interested in this because it tells them a lot about the planet's air. The James Webb Space Telescope can see thermal stuff, so it can check out the planet's heat and figure out what's in its air. Here's a fun fact. The James Webb Space Telescope goes around Earth at the same rate that Proxima Centauri b goes around its star. So, scientists can watch its days every 11.2 Earth days. If Proxima Centauri b has air, the next thing is to see what's in it to find out if life could live there. Seeing things like oxygen, water vapor, and methane would mean it might be able to hold life. This means studying the light that goes through the planet's air, which is complicated. The James Webb Space Telescope is awesome at figuring out what's in a planet's air. What it's good at is analyzing water vapor, carbon dioxide, and methane concentrations. However, it's not as good at seeing free oxygen, which is a major sign of life. Still, it can look for other things like ozone, which suggests the air is doing well. As scientists look at the data from the James Webb Space Telescope, the hunt for other planets keeps going. We're getting closer to knowing if we're the only ones out here. Keep in mind, the James Webb Space Telescope can only see some of the closest planets. For more in-depth looks at planet air, astronomers will count on telescopes on the ground, like the Extremely Large Telescope, ELT, which should be up and running in 2027. The ELT is built to see deeper into the air of far-off planets, giving us clearer data about whether they could have life. Scientists are pumped for future space telescopes like the ELT. In the meanwhile, the James Webb Space Telescope is still great for checking out far-off planets. Even with its limits, it keeps giving us important info that could change how we see what's out there. Researchers have big plans for future space telescopes. They want to create tech that reduces light from stars, so we can see the planets around them better. It's like using your hand to block the sun so you can see better. These telescopes will be able to focus on the faint light from planets, making it simpler to check out their air and see if they could hold life. It's not easy, though. Stars are super bright, usually much brighter than the planets around them. This makes it hard to spot the faint light from planets, which we need to study them. To deal with this, scientists are working on some cool ideas. One is using coronagraphs. These are devices inside telescopes that block out light from stars but let light from planets through. By carefully shaping the light waves, coronagraphs can lower the brightness from stars, so it's easier to see the dim light from planets. Another idea is the star shade, a huge spacecraft shaped like a flower that will information with a telescope far away. The star shade blocks light before it even gets to the telescope, so only the light from planets reaches the tools. This could be really good for seeing planets in the habitable zone of their stars where water and life could exist. These tools need to be super precise. For example, a star shade has to be lined up perfectly, within tiny fractions of a millimeter, over huge distances. Also, these projects must deal with the limits of space missions, like being small, using little power, and surviving rough conditions. If we can pull this off, the rewards are huge. By seeing and checking out the air of planets, we could find biosignatures. These are chemical signs of life, like oxygen, methane, or water vapor in certain amounts. These could point to life processes. Researchers are also trying to directly take pictures of distant planets in more detail. Future telescopes could have adaptive optics, which fix distortions from Earth's air or the telescope's movements, making pictures clearer. With starlight blocking tech, we could not only spot planets but also map their surfaces and study their weather. Building next-gen space telescopes is a big jump in trying to answer one of the biggest questions. Are we alone? The future of space stuff and looking for life is going faster than ever. As scientists check out the secrets of planets, the James Webb Space Telescope is starting a time of big finds. The info it gets is helping astronomers make discoveries about the structure, makeup, and living potential of faraway worlds. With each new bit of info, we get closer to answering that big question. Is there life out there? The discovery of Proxima Centauri b is a big start in maybe changing how we look at life out there. Because Proxima Centauri b is the closest star to us, it's been researched a lot. But finding real proof like artificial light or cities has been a dream for many scientists. The fact that the telescope saw this light makes us hope that maybe we'll talk to other life forms. This kind of find gets scientists and everyone else excited, inspiring new generations to think beyond Earth. As the James Webb Space Telescope keeps watching, it's not just looking for lights but also checking out planet atmospheres, what's in them, and how this could help life. The search for biosignatures such as methane or carbon dioxide is key to knowing if they have the right settings for life. The telescope can look at these parts of the air in ways others couldn't before, shining a light on planets. One cool part about Proxima Centauri b is that it's in the habitable zone where water could exist on its surface. The habitable zone is where the temp is just right, not too hot, not too cold for water to form. Because water is key for life, finding a planet in this zone is a big target. Beyond finding planets that could hold life, future space telescopes will check out the relationship between planets and their stars. Some planets are tidally locked, so one side always faces the star, while the other is dark. This can make big changes in temp, which would affect the climate and chance for life. It's really important for astronomers to understand this. Building tech that can block out bright light from stars is huge. Really, without this, it'd be hard to see the faint light from planets. The ideas like coronagraphs, which scientists are fixing this. Another cool thing is directly imaging planets. With telescopes, we can snap photos of planets as they go around their stars. Not only would these photos give more info about what they are composed of, we could also look closer at surface features like oceans or weather. Proxima Centauri b and its star are really connected, and the star has a big impact on the planet. It's like any other planet orbiting, it catches a ton of energy from its star. As it goes around the star, it has day and night. Just like Earth, it gets super hot during the day and cooler at night. The temperatures on Proxima Centauri b can change a whole lot, mostly because of what it's made of. If it has an atmosphere, the temps would be crazy different between day and night, hot on one side and freezing on the other. This huge change in temp is something astronomers are watching closely, because it tells them a lot about what's in the planet's air. Thanks to the James Webb Space Telescope, we can look in the infrared and see these thermal emissions, giving us clues about the atmosphere. Interestingly, The James Webb Space Telescope's orbit around Earth lines up with Proxima Centauri B's own orbit. Because of this, scientists look at its daylight cycles every 11.2 Earth days. If Proxima Centauri b actually has an atmosphere, the next step is to figure out what it's made of. If there's stuff like oxygen, water vapor, and methane, that would mean it might be able to support life. This means studying the light that passes through the planet's atmosphere, and that's not easy. The James Webb Space Telescope is great for figuring out what's in the air, the amounts of water vapor, carbon dioxide, and methane, but it's less good at finding free oxygen, which is a major sign of life. Still, the telescope can look for other clues like ozone, which means atmosphere is healthy. As scientists look at the data from the James Webb Space Telescope, the search for other worlds goes on. We're getting closer to knowing if we're alone in the universe. It's worth remembering that the James Webb Space Telescope can only check out the exoplanets that are closest to Earth. For more in-depth stuff, astronomers will use ground-based places like the Extremely Large Telescope, ELT, which should be up and running in 2027. The ELT should give us a better look at the atmospheres of exoplanets, as well as more information to see if that life could exist. Everyone's waiting for new telescopes like the ELT to come online. In the meantime, the James Webb Space Telescope is still useful for checking out exoplanets. Even though it has problems, the Webb telescope is still giving us facts that may change how we view what lives beyond our solar system. Researchers have big dreams for future space telescopes. They want to build tech that cuts down on the interference from starlight so they can get a better look at planets. It's like shielding the sun so you can see better. These telescopes will be able to zoom in on the faint light that exoplanets reflect, making it easier to check out their atmospheres and see if Earth-like conditions could exist. It's not easy, though. Stars are super bright. This makes it tough to see the faint light from planets, which we need to check them out. That's why scientists are coming up with cool ideas. One is using coronagraphs that cut off star light, while still letting planet light go through. By reshaping the light waves, it is possible to reduce the brightness of the star, which can allow us to see the faint light from exoplanets. Another way is with a star shade, which is like a huge flower-shaped spaceship. It would fly in space with a telescope and block starlight before it even gets to the telescope. This is a good way to see planets in the habitable zone, where liquid water and life might exist. The catch is that these technologies are extremely complicated. Take alignment of a star shade. It must be perfect down to fractions of a millimeter. These need to also handle problems that come with space missions, for example miniaturization, energy efficiency, and the conditions in space. The rewards are well worth it. If we can check out the atmospheres of exoplanets, we might find biosignatures which indicate life. For example, oxygen, methane, or water vapor could point to organisms being there. Researchers are trying to directly image faraway planets. Future telescopes may have advanced adaptive optics, which means they can adjust for disruptions caused by Earth's atmosphere, as well as movements of the telescope. This gives way to clearer images. With light-blocking technologies like these, we can maybe map the planets and study their climates. Developing future telescopes will help us know the answer to one of the biggest questions that humanity has. Are we all alone? By upping this toolset, it offers the chance of finding life exists beyond Earth. Things are happening fast in space discovery and in the search for extraterrestrial life. As scientists are studying the mysteries of exoplanets, the James Webb Space Telescope is revealing a time of discovery. Data from it aids in great findings about the structure, makeup, and probability of living species on exoplanets. Each find brings us closer to answering the questions: is there life out here? The Proxima Centauri b discovery is perhaps a turning point for studying life outside of Earth. Being that it's near to our solar system, its focus of research. The fact that there's lights coming from space is exciting to the science community and helps us believe we might find intelligent life forms in the universe. As the James Webb Space Telescope continues its research, it's trying not only to find lights, but learn about the atmosphere of planets, and how all of those factors relate to conditions needed for living organisms. One of the reasons Proxima Centauri b is interesting is it sits in its star's habitable zone. The habitable zone has the right conditions for water to be there. Future space telescopes will focus on relationships between stars and planets. For example, Proxima and Centauri b are locked, so they stay in the same facing position at all times, can affect planet climate. The blocking of bright lights from stars is also a major step. The coronagraph and shade that were spoken of earlier. These tools will allow telescopes to see the light coming off planets, revealing data on planets like what conditions there may be to thrive for life. Another thing is imagery for planets. It's hoped that through optics and technologies that we can take nice photos of planets as they rotate. These could offer data on structures or atmosphere. As exploration continues, space telescopes will be needed. They are able to analyze conditions for life. This is transforming knowledge of the cosmos. We are close to discoveries in our knowledge of life due to how much research is becoming accessible.